Hi, I'm Kyle with Kimray, and today we're going to be talking about the lever-operated liquid dump valve. We're going to be covering how it operates, the applications it's used in, and some troubleshooting ideas. Lever-operated liquid dump valves can be used on separators and knockouts to either dump water or oil. These are paired with our trunnion assemblies. The trunnion assembly is what connects to the vessel with the float and float arm. They are mechanically linked together, the trunnion and the liquid dump valve. We'll go over that in just a second. A lot of people refer to these as mechanical dump valves. I still do. That's how I was taught. We kind of went through a renaming, and now they are lever-operated dump valves. But you might catch me saying mechanical valve, but I'm talking about the same thing. The connection types for these liquid dump valves, we have threaded as well as flanged, and then we have angled and through bodies in both of those versions. So it can fit a wide variety of connection sizes and types. Here you can see a couple of pictures of these dump valves in action. On the left, you see the float going up and down with the liquid level inside of a separator. This is just a two-phase separator, so we're separating out gas from liquid. The float rises and falls with the changing liquid level. That in turn pushes the linkage arm up or down, opening and closing the dump valve. Now, when we're talking about liquid levels, two-phase, so like I said, just separating gas and water. These can also be used in three-phase, so we're separating oil, water, gas. The interface level controller, the interface float, has to be weighted if you're going to be using it in a three-phase separator. That's because you want it to sink through the oil, but only operate on the water. So still buoyant in water, but has to sink through the oil. We have a couple of videos on this process if you're wanting to know how to weight a float. These lever-operated liquid dump valves work with trunnion assemblies. We have them from 2-inch all the way up to 6-inch. The Diaphragm Balanced is rated for 300 pounds. That's in a threaded body. The flanged version is rated for 250. If you move up to the Piston Balanced version, you can go up to 500 pounds in the threaded body. Technically, we say low pressure is anything under 500 pounds in this case. A lot of the times, the float inside of the vessel is going to determine how much pressure you can put on that. In a second, we'll look at the floats, but that is normally the weakest point of this system other than the dump valve. So you just be aware of what float you have and the operating pressure of that float. I've seen it before where floats have been collapsed just because the operating pressure of the vessel was too high. And if a float collapses, it's not going to be buoyant. It's not going to control liquid level in your vessel. Causes a bunch of problems, obviously. We also have a PBT, or Piston Balanced Throttling dump valve. We have that in 2 and 3-inch sizes. The flow path of the PBT is a little bit different from the other lever-operated liquid dump valves in that the flow comes up over the seat and the seat moves up out of the way. So it's not obstructing the flow path. You get a little bit higher volumes, and it works a little bit better with abrasives or erosion. So here we can see the internal design of this dump valve. The one I'm looking at here is the older style. It has the keyway on the shaft, and that change was made from the keyway to the double D design. The keyway was a good design. It did not make repair of this valve easy. After so long in service, that keyway would get rusted. There was really no easy way to get that out and repair the valve. Here's the new design, the double D. So that gives a lot more contact area than the old keyway design, where all the torque all that force was on that key. Now there's two flats on this new design gives it a lot more rigidity and makes repair a lot easier. So as flow comes in to this connection here, it rests on the seat. Now these are a balanced valve, that's why they're called Diaphragm Balanced and Piston Balanced. So the downstream pressure is balanced both underneath the seat and then on top of the diaphragm. And that's communicated through the hollow stem. So no matter the pressure drop across the valve, the lever-operated liquid dump valve can open and close more easily. But as the liquid level rises in the vessel, that linkage that connects the trunnion assembly to the dump valve will be pushing down on this arm. When you push down on the arm, that engages the stem, the linkage internal of the valve, and then pushes down on the stem, which opens up the seat. As the seat opens, you'll get flow through the valve. Liquid level will start to decrease in the vessel, and that will cause the float to move down, which eventually will, through the linkage rod, will pull up on the mechanical valve's arm, which will then close the valve. It's a soft seat design, so there's a soft seat down here, so you get a bubble-tight seal on this valve, so there shouldn't be any leakage past this valve when the valve is closed. So what I mean by bubble-tight seal, it's a Class 6 seal. It's just a soft seat seal. The bubble-tight rating is there's a standard that says so many bubbles can pass through or will not pass through a bubble-tight seal. An example of something that does have an allowable leakage would be like a metal-to-metal seat or a Class 4 seal. There's a certain amount of allowable leakage or bubbles that can go through a metal-to-metal seat. A bubble-tight seal means under certain pressure drop, no bubbles were able to escape or no leakage could get across that seal. So that's what I mean by bubble-tight seal. As you can tell with this design and the piston balance, which we'll look at next, the flow is going to be impeded by the seat. As the seat comes down, the flow has to go around the cage and then around the seat. So if you are fighting abrasives, the seat is definitely a point of wear that can wear out rather quickly. That's why the PBT was designed to prevent that erosion from happening. We have a Delrin cage that is used in the diaphragm balanced valve. It's designed in such a way that it cannot fit inside the piston balanced valve. We've had a few customers call and say, hey, this Delrin cage won't fit in this mechanical valve. Come to find out they were trying to put it inside of a piston balanced valve. The reason why we designed it not to fit in that one is because the Delrin's not rated for the operating pressure that the piston balanced valve can operate at. And so we designed it so that it would only fit in the diaphragm balanced valve. So that's intentional. If you're ever having problems you're doing a repair and you cannot get the cage inside the valve body, that might be the cause. So give us a call and we can help you work through that to make sure you have the right valve body or the right cage. But any piston balanced valve is only going to have metal cages. They don't have the 304 DEL. That's the 2-inch part number for that cage. But it should always be a metal cage inside of any piston balanced valve. Here we're looking at the piston balanced valve. This one is rated for higher pressure than the diaphragm balanced valve. This is still a balanced valve, so we're still taking the downstream pressure and communicating it up above the piston through the stem, through the hollow stem. But because it's a piston, so it's got a metal piston instead of a diaphragm, it can operate at higher pressures. Here we're looking at the piston balanced throttling valve, or the PBT. Now you can see right away there's something else going on here. It looks a whole lot different. So as liquid level increases in your vessel with this one, the float is going to have the same action. It's going to rise with the fluid level, which is going to push down on the valve arm through that mechanical linkage. But instead of the seat opening down, now the piston is pulled up out of the flow. So as upstream pressure begins to flow when this valve opens, the whole piston assembly is moving up out of the way. So if you have abrasives, if you have sand, we're getting those parts up and out of the way, so that way they're not wearing out. That also helps the valve body not wear out. If you look at the downstream side of this valve, there's nothing impeding the flow once this valve opens. If we go back to the piston balance valve here, you can see when that seat opens, it's still in the flow path, and that flow has to work its way around that seat. And that pushes that flow and that velocity out towards the valve body, and you'll actually get wear on the valve body, and potentially, you could wear a pinhole in the body in this larger cavity on the downstream side. Right here on the side walls, you'll start to see wear if there's enough abrasives or enough sand in the flow path. Next, I want to talk about trunnion assemblies. I've talked a little bit about them in the float that they connect to inside of the vessel, but we have these available in 6, 8, and 10 inch. Those are with the flanged options, and those are only rated to 250 PSI. So keep that in mind when you're choosing these products to make sure that the operating parameters are going to meet the operating pressures of the equipment that you choose. It also depends on what size float you're going to be using. You want to make sure that either the flange or the hammer union that you're using is large enough to fit the float, because that's the only way to get the float in, unless there's some other kind of manway on the vessel. But you want to make sure that your float can fit through whatever trunnion you are choosing. Here are some of the floats that we have available. The most popular float, or the most common, is going to be the 7 by 12 inch float. You can see here, they've got the weight of the float, the displacement or its buoyancy, and then also the working pressure. The 7 by 12 is rated for 600 pounds. So the 500-pound vessels that it's going on, it shouldn't ever have issues with collapsing. There are other floats available that have, maybe with the 5.5 by 14, maybe you have a smaller trunnion and you need a smaller diameter float to be able to fit into that. So that's why we have different options with floats. Some of the larger floats get you more buoyancy. That translates into more torque communicated to the valve. So as you increase in operating pressure on your separator, the more torque is required on that mechanical system to be able to open and close against that pressure. And I'm going to show you guys a torque calculator. We have this available on our website, so you guys can go on there and search for it and find it, and you can follow along on our website. And I'm actually just going to jump on our website and look exactly at what you guys are looking at. Okay, so after you've downloaded the torque calculator from our website, this is what you'll be looking at. You can input conditions into this calculator, and it will give you the torque requirements. A few things go into this calculation. The float weight and buoyancy, as well as the rod length. So that's the length of rod between your float and your trunnion. And then you also everything on the outside of the vessel. So your length of your levers on both your trunnion and your dump valve, as well as the placement of the linkage rod. With that, the further you get away from the fulcrum point on both the trunnion side and the mechanical dump valve side, the more torque you're going to have. But what you gain in torque, you also sacrifice in how much the length at which the valve has to travel to open. So if you want more torque to be able to open against higher pressures, that float is going to have to travel a greater distance inside of the vessel, and the valve will more or less open more slowly. So it's a give and take. You have to decide, your requirements on opening and closing torque, and then also, if you have higher flows and you need the valve to open more quickly, you may just want to go just beyond the point where you have just enough torque to open and close the valve. But that way you're not lengthening the time or changing the span of liquid inside your vessel where you're outrunning your sight glasses. You can keep a tighter span inside of your vessel if you don't increase the travel length too much. A lot of the time you're going to be using hollow float rods, and that's okay because the float, if you have not weighted the float, if it's a brand new float coming from us, it's completely sealed. One thing to keep in mind, if you do weight your float to be used in interface level control, you want to use some kind of sealant on the threads from your float rod to your float, because you have to drill a hole in the collar on the float to be able to weight it with, production fluid, sand, BBs, whatever you have. And that's a potential leak path from inside the vessel into the float. And if your float gets filled with fluid, it's not going to float anymore. So if you do weight your floats, just make sure that you're sealing those threads so that way no fluid can get inside of the float. So on this side of the sizing calculator, this is where you input all of your information. The specific gravity of the fluid, the float length, volume, and weight, and you can see the reference of the different tables on the left. So you just follow along, find out your information, and then this table 4 below here is talking about the requirement to open. So on the left side, you have the pressure differential. So this would be the differential across the dump valve. So let's say you have an operating pressure of 100 pounds on the vessel, and then you have 20 pounds downstream of the dump valve. That gives you a differential pressure of 80 psi. So in this example, let's say we're using a 2-inch valve. So at a differential of 80 psi, a 2-inch valve requires 130 pounds of torque to close the valve. To open the valve, we need 960. The larger the dump valve is, the more torque it's going to require to open that valve and to close that valve. A common mistake I see people make with these is that they oversize their valves. Let's say you put a 3-inch valve on a vessel, but it's really low flow, less than 1,000 barrels a day. I see this all the time. People put 3-inch valves just about on everything, and they're always oversized. And that does a couple of things. That's going to wear out the valve a lot faster than a properly sized valve. And it's also going to require more torque to open and close. And so you're going to see a lot more issues with an oversized valve than you would with one that's sized properly. So I would encourage you guys to size the valve for each application. Make sure that you're within those operating parameters as far as flow rate for the valves. And that's going to save you a lot of headache down the road if you do that work up front. And you can always call us and we'll help you size those valves and make sure that you have it set up where there's enough torque generated to open and close the valve properly. I want to take a second and talk about what an oversized valve looks like, or what a valve that is not getting enough torque from the float and float arm and the whole mechanical linkage, and what that looks like. With an oversized valve, it's going to be opening and closing very quickly. It's not going to be a smooth action. It's never going to open up very smoothly and then close smoothly. Because it's oversized, as soon as that valve opens, the liquid level inside of the vessel is going to drop very quickly. And so that valve is going to close immediately. Then it might open up quickly, then close. That's a common sign of an oversized valve. On the flip side of that, if you have a properly sized valve, but maybe it's the torque requirements or the setup you have with the float length and weight and the length of the linkage arms and where they're positioned on the levers on the trunnion and dump valve, if that's not set up correctly, you could not be generating enough torque to open or close the valve. If you see a valve that seems like it's sticking open or maybe sticking closed, you're not generating enough torque to operate that valve. If it's stuck closed and you go up and you just have to put a little bit of pressure on that arm and then it springs open and it won't close, or it springs open and springs shut, that's a sign that the torque requirement is too great for your setup. So play around with the linkage on the outside of the vessel. Move the linkage on the trunnion side further away from the fulcrum point or further away from the vessel. And then on the valve side, you'd be moving the linkage arm further away from the valve or closer into the vessel. That's going to increase the torque. I would do it incrementally. Don't make a big jump all at once. Make subtle changes and see how the performance of the valve changes before you do like drastic changes to it. The last bit of information I'm going to leave you guys with is about our adjustable packing. I've had customers that I've talked to say, when they adjust the packing, the valve stops working. That is typically because they have over-tightened the packing. If your packing over time will wear, and if the valve begins to leak, the adjustment to the packing needs to be very little. Even 1/8 of a turn will usually do it. If you tighten the packing too much, it can prevent the valve arm from moving at all, or it can slow it down enough to affect the valve performance. So tighten it just enough to stop the leak, but keep the valve operational. We have a ton of other content surrounding the lever-operated liquid dump valves. We have repair videos, videos on the updates to the hub and to the packing. So we'll leave links in the description below so you can find those videos easily. And I want you guys to comment on what you found helpful in this video. It's helpful for us because we can know what we missed. If you know something about the mechanical valves, some experience, please leave a comment below. We'd love to interact with you guys. If you want this type of training in person, you can visit our training and demos page on our website. You can schedule the training from there. Thanks for watching.